Anyway, so now let's work this out to have a closure of the law of sines. They say there are two fire lookout stations 13 miles apart, right? The station B is directly east of the station A. So let's have a diagram just to, visualize what's going on. All right, so B is to the east of A. And they are 13 miles apart from each other. So they noticed a fire. So from the point of view of station A, they see the fire at the bearing. I hope you still remember what the bearing is. At a bearing of north 35 degree east. All right, so again, just to have an idea, like, those directions. This is north, south, right, east, west. So it is to the north, right, but turn to east, right, by 35 degrees. So you're looking at north, turning to the east. This is probably where that fire will be. All right, so this is 35 degree. So I don't know where the fire exactly is, but it has to be along this ray. Right? Could be here, but it has to be along this line. Now, from the B's point of view, it will be still to the north, but north 49 degree west. It's going to turn to the west, right? It will be something like this. Or you know what? I could maybe, I should have made this a bit shorter. Yeah, something like that. Yes, it does. So these two rays will intersect, right? And the ray that I just draw for the station B, it starts from the north, turns to the west by 49 degrees. And when they intersect, that's where the fire is. That's called F. Now, what are you asking for? Where is the fire? How far it is away from the station B? That means we're looking for the length, right, of the segment BF. So I'll put a question mark there. Exactly, right? So you see that after you reading, extracting the information, and draw that little sketch, you realize this is a problem solving triangles. Now, if we're solving triangles, we need, just like Russell says, we need angles and sides, right? We need to know as many of them as we can. So in a triangle ABF, what do we know? Oh, we know side AB, which is 13. And then we know the opposite. Oh, we do? Let's see. Now, how about we figure out these two angles first? Because we want interior angles, right? How much do you think this angle has to be? Let's call it angle A instead of FAB. 55, right? It's related to the 35. It's the complementary angle, right? So let's put it down. This is 55 degree, right? So I'm sure that you see this one. It has to be 41 degree, right? Again, the complementary angle of 49. So now we have the angle A. Instead of putting AFB, angle A is going to be 55, right? In the triangle, we know angle B is 41 degree. We know two angles plus the side, right? So we can figure it out BF, right? So now what we need is the law of sines. And you notice that the law of sine is in a pattern that you always take the side divided by the sine of the corresponding angles. So I need the BF. And I do know the corresponding angle 55, right? Let's go ahead and put BF over sine of that angle, which is 55 degree. So it better be another side, right? Oh, we do know 13, right? 13 over sine of an angle, let's call it F. But we don't know the angle F. At least not directly, right? Can we figure out the angle F, which is on the very top? Yes, right? So F is easily calculated by subtracting both 55 and 41, right? And I believe you get maybe 84, if I remember correctly, 84 degree, right? So now let's go ahead and put A4. And you know what to do, right? Cross multiplication, right? And you figure out what BF is. It will be 13 times sine of 55, right, over sine 84. Okay. And you will figure out what that is, right? And it's in miles. That's it. So it is a typical problem about solving a triangle, but they hide it behind a real world situation, right? But that's exactly the part that makes the problem, a little bit harder than a more straightforward version, right? And that's why, the last problem on the test, right? So you realize that the math you have to do is the same as what we did in class. But what bothers people is they couldn't get started. The first part, as reading the problem, trying to figure out what to do, they stop at that level. Okay. But yeah, that's the end of 7.1. And I'm gonna have to urge you guys to seriously start looking at those problems in the quiz. All right, so at this point, you should be able to easily work out questions from 1 to 8 with no issues at all. You just have to do it. All right, if you haven't done it, I guess that, I'm not saying that you have to do it, because you do have SAT, right, coming up. But I mean, maybe right after class, right, spend 30 minutes, work these out. All you need is just 7.1, refer to my recording or ask me for the notes if you want. Figure them out, have your work ready, right, save them in a notebook. Then, you just have to come back maybe in a few days after the SAT, right, review them, then you're ready for the quiz. Okay. And I'm going to actually start 7.2. I'm not able to finish it, but I'll be able to get to a decent point, for 7.2. And people were asking me when I'm going to be done with 7.3. I'll say next Monday. Right? But you know that there's no teaching tomorrow, right? So pretty much today, right, we'll get to this point of 7.2, wrap it up next Monday, and I'll try to hopefully finish 7.3 next Monday. Right? Now, but if I finish 7.2, say next Monday, then you should be going all the way to, you see that question 14 on the quiz packet. Okay, don't wait until you are about to come back, right, to do the quiz, and you start working on those problems. 1, 2, or a couple problems every day, right, get them done, because it shouldn't really take you that long. If you just had a lesson about these things, right, you had those examples, then you go ahead and just reproduce the work, and not to mention the answers. Okay. All right, now let's see, 7.2, law of cosines. What I did yesterday with my 1 p.m. class, it was, of course, not what I had planned, but, we're at the point of approving the law of sines, like I did for you guys yesterday, right? And I was able to even get to the proving of the law of cosine. But I know that, maybe it's not something that everyone's interested in, but I do have it recorded. So if you do want to check that out, you can check the recording for yesterday. You did? Didn't know you recorded. I didn't know you recorded. I'll be heartbroken if you check that out. All right, so the proof of sine and cosine, from the recording of yesterday's class. So I'm not gonna do it, not that I don't care enough for you guys. I just, don't have the time to do that. But it will be a very good way for you to interact with another very powerful law. Now, let's just jump right into those formulas. And my first year students asking me if there could be more extra credits, right? So I'm sure that you guys can always use some extra credits, so that's at least for this semester, right? So I asked them that, hey, what if I give them a quiz just about the law of cosine, law of sine, and all you have to do is put your name on the paper and write down these laws perfectly. All right, so letter by letter, have exactly the way you see, like that. Okay, I'll add that. No. So law of sine, law of cosines. Right. So that'll be a quiz. I'll give you a couple points, right? As extra. It's always gonna do something to the overall grade, right? How would they like that? They loved it. So I guess that, but I want to be fair. If I want to give them a quiz worth some extra credits, so better make sure that I do that for every class. So would you guys like a quiz like that? Not right away on Monday. How about that? Don't worry about it, until maybe the weekend. So on Monday, right? It's just a quiz. It will take no more than 5 minutes, right? Put your name down, right? To claim your points. Write down the law of sine, which has been there forever, right? Law of cosine, right? All 3 versions. But then, the class and I, started to share the way, maybe some smart ways, to memorize them, because if that's all you have to do. And students have their own way, and I have my own way, right? So again, it doesn't matter how you remember them. What matters is if you do remember them. That's all. Okay. So let me spend just a couple minutes to make sure that if you have some cool ideas to remember them, please share with us if you like. If not, I mean, at least that I'll share with you my way, and feel free to look up on internet. First off, let's say take a look at the last one. Do you see that it's taken a form of a theorem that you actually know very well, right? What is it? Pythagorean theorem, right? So it's c squared a squared b squared, right? Then one of the students in the first period said that it's the Pythagorean theorem plus like a tumor. So you hate it, right? You want to get rid of it, but you kind of have to carry it. Not you, I'm saying that unfortunately, right? So you have to carry that, the law has to carry that term. So that means all you have to do is make sure that you have a way to remember this extra term, right? So it starts out with a negative sign. But if you remember, there will be a negative sign, right? I remind you, it's not going to be plus, negative. And there's a factor 2. Have you ever seen a factor 2 in an AB somewhere else? Was it a formula back then? You guys probably don't use that very often, but you know that I like to mention that all the time, right? And it's called, oh yeah, Logan? But it is a 2 in it, right? So is it b over 2a, something like that? But what I'm actually talking about is the perfect square trinomial. A plus b, right? And you know what? That factor 2 came from expanding the perfect square trinomial to prove the law of cosine out of the Pythagorean theorem. And that's why you're looking at something that you used to know. Okay. So now I think that it shouldn't surprise you have a 2ab with a negative. So now you have a cosine, right? So how do I remember it's going to be cosine? Look at that law. It says law of cosine. Don't you want to put cosine there? You're not going to put sine here, right? So the cosine of some angle, right? What angle would you put it there? My way of remembering it is, you see that it's in alphabetical order. A, B, C. We're going to put the big C because that's an angle, right? Those little a's and b are the sides. Or one of the first year students said, that C matches the C all the way on the other side. If that's a C, that's a C. If that's a B, that's a B. But that's a side, that's an angle. That's all, right? So now let's say, you don't have to take my way, but let's say if you remember the last one, You like it so much because it's in the form of the Pythagorean theorem, a squared equals b squared, c squared equals a squared plus b squared with that, I mean, a tumor term. So how would you be able to recreate the other two forms? So my way of doing it is imagining those letters can move. Like students, right? They step out of their seats and try to take some other spot. Let's say the A step out and say that it's going to come to the left to take the C's, the spot of the C. B is going to come over to take the spot of the A. And guess what? You're getting to the first one. See that? It was A here, shifted to the left. It was B, shifted to the left. Now C, turns out there's no C for C, right? On this side, so come all the way here, right? So that's shuffling them. Now, when it comes to this term, it was ABC, right? Well, guess what? A come all the way back to take the spot of C, or B shift over to the left, and C come over to take the spot of B. But when the C come out, it becomes a lowercase because these two has to be the sides. Sounds complicated, right? Because that's my way, you know. It may or may not work in your case, right? So if you have any way that works out for you, you know, by all means, go with it. Because at the end of the day, all I care is, let's say if we decide to do the quiz next Monday, you need to write down these three equations perfectly. I don't care how you do it, right? But, you know, memorize, you know, however you want. But at this point, you know, I'm assuming that you could either remember, you know, maybe some of you already remember them, right? But you can always look it up, right? Now, let's try that with a actual problem, right? To see how I like it compared to the law of sines. So they emphasize it's the SAS triangle. The reason why they want you to realize this is the SAS is because, you know, now you have two options, right? If you're trying to solve the triangles, most people is going to go with law of sine because it looks easier because there's no whole lot of squares. And that's the first thing you learn, right? Somehow, you know, if you're a natural, you always use it. But you need to know that sometimes you're better off with law of cosines. But when? And this is probably the best situation that you better use the law of cosine. So what happens is, if you're given two sides and an angle in between, use the law of cosine. Okay, that's what they call it, SAS. So yeah, we know the we know the angle A, right? We know the B and C, but we're missing that little a. So let's see if we want to find out what the 8 is. How about we try to write down the law of cosine that starts with a squared all the way on the left? Can you guys now do it just by learning it, you know, a couple minutes ago? What should I put? Malachi? Oh, no, sorry. I thought you wanna try it. Uh-huh. BC. Yeah. So those two letters are the same, right? The one you have, not A anymore, right? Okay. Cosine A, right? The one that matches the A on all the way the other side, right? Good. Now, do you see that we have everything, right? Little b, little c, right? And angle A. That means A will be the square root, right? You have to take the square root. So b squared, which is 7 squared, plus c is a squared minus 2 times 7 times 8 times cosine of 120 degree. And do you see that it's ready to go, right? And I'll go ahead and find out what the 8 is. Okay, thank you. Oh, it's actually exactly 13, I think. 13 units, right? So now we have it. Oh, that's bad. All right, so now, oh shoot, sorry, I'm sorry. Hello. Hey. Hi. Yes, yes. Sorry. Mhm. Uh-huh. Uh-huh. Right. Uh-huh. Right, right. Mm-mm. Mm-mm. So basically he's 30 minutes late to aftercare. And he was somewhere playing with some other kids, from the same grade level. Okay, okay, okay. And what consequences did he get? Okay, okay, got it. Okay, thank you. Yeah, I'll talk to him. That is from my kid's school, so I kind of have to take it. Um, what I was talking about. Oh yeah. So now at this point, we need to figure out two remaining angles, right? Which are still missing. So either angle B or angle C. There's no order that you have to follow to get either B first or A first, right? Yeah, inverse, yes. But my question is to find the angle, let's say B, would you guys use law of sine or law of cosine? Given whatever you know at this point, we know all three sides, right? Plus an angle, right? Would you prefer, or what was the first thing that came to your mind? Law of sine or cosine? Law of sine. Some say, Karina, is that what you said? Law of sine. Okay. I think that's probably most people would also pick, right? That makes sense. Let's try it. So let's say if you want to use the law of sine, that means we need to find out what sine B is, right? So you see the format, right? It's going to be the side of the opposite, right? So that will be little b over sine B equals, so now let's say, oh, I know the angle A, right? Let's do the opposite of angle A, which is little a over sine A, right? So then you plug in whatever you know. So, and do the cross multiplication. So I have A, which is 13, times, that's not a B, 13, times sine B equals A, then, okay, 7 times sine 120. Let me get this out of the way. And we can figure it out what sine B is, right? I'm sure that you can do that, right? And later you're going to invert it to get the B. And I was told by my first year student, so that should be around 28 degree. You guys all get that? It's 38. Huh. Hmm. How come they told me at 28 degrees? Did I do this? Let's say B is 7, 120. Okay. A and a B. Is 38 degree? Did anyone else get something? Like how much is the B? Can I have confirm? Is it 28 or 38? I wish I have a calculator with me. Yeah, guys, double check, because more than one student got 28 degree, 1 p.m. Let me see. You know what? Let me write it out. All right, so so what we do is sine B is 7 times sine of 120 divided by 13. And this is, it is 28. That's okay. All right, B is approximate 28 degree. Again, double check that if you get a chance. And now once you get B, you can find out what the C is, right? But what did I tell you in the past like 1 or 2 days? Can B be a bit different than 28 degrees? Would there be another angle? Would be that could also work out? Remember the ambiguity in a sign? B could be 28 or it's 152, right? 152, that's the supplementary or the reference angle, right? That will still work out. Remember that? That was what we did, yesterday, right? The ambiguous case. But in this case, would you keep both of them? What's wrong with 128? Not 120, 152. It's too big. So, but I still like to see that you put down both angles, but later you eliminate 152 by telling me that it doesn't work for this triangle. It's only one unique triangle, and the angle B has to be a small one, which is 28. Okay. But how do you guys? Oh yeah, Alex. If you're getting an angle from the inverse sine, you need to at least have your mind open to another possible angle. But you also have to make sure that, we're not keep both or only keeping one of them, right? And it will be as easy as to check if you have any room for the third angle, right? But the thing is, I was trying to ask you guys, how do you like this kind of ambiguity? What if you forget, right? Is there a way you can, now there's no way out, previously when you have the ambiguous case, because there has to be two angles, right? But in this case, turns out there's only one angle, and it's going to be 28. How would you make sure that you don't even have to face this kind of choice and you end up being still taking the 28 degrees? So I'll say that why don't you try the law of cosine. Now, what did I say about when will be the best time for you to try the law of cosine? SAS, right? That means if you're looking for an angle, let's say B, if you provided the two sides, well, the angle is in between, right? We call it included angle. Try law of cosine. And what? How about you guys tell me the form of the law of cosine that starts with B squared? You know why I'm trying to B squared, right? Okay, now go ahead. Equals A squared, C squared, minus AC or CA, right? Yeah, cosine B, yeah. But now in this case, unfortunately, that you don't have the cosine B isolated for you. You just have to do it on your own, right? Now, but we have everything, right? Let's see. We have B squared, which is 7 squared, equals A squared. Wait, A is 13. Well, it doesn't matter the order, but 13 squared plus C is A squared minus 2 times 13 times 8, right? Cosine B. How would you solve for the cosine B? Let's subtract 13 squared and A squared from both sides. Right, so those two are gone. So left with 7 squared minus 13 squared. Oh, by all means, you can work them out. I just don't have the calculator. I don't want to do the math in my head. That's equal to negative 2 times 13 times 8, right? Cosine B. And, just by dividing out whatever numbers that was multiplying the cosine B, you're going to get cosine B by itself. It will be 7 squared minus 13 squared minus 8 squared over negative 2 times 13 times 8. Okay, am I right? Yeah, okay. And once you get whatever that is, you invert the B using the inverse cosine, right? And it turns out to be roughly 28 degrees. Okay. And there's no ambiguity with the cosine, thanks to the range of the cosine inverse. A quick check, see if you remember. If you don't, that's fine. What is the range of inverse cosine? Range of inverse cosine. No, it's an interval, right? 0 to 2 pi. Anyone else? Not saying that you're wrong, but I just want to know 0 to pi. Anyone else? Yeah, because there's something like a negative pi over 2, pi over 2, right? Stuff like that, right? Or real numbers, right? It turns out it's 0 to pi, included, right? Inclusive. What does 0 to pi means? 0 to pi means that it's from 0 degree to 180 degree, right? That means you will be getting any angle from cosine inverse right off the back, which can be an angle from 0 all the way to 180. But are you supposed to get any angles greater than 180 in a triangle? No, right? That means cosine is going to tell you exactly what angle you're supposed to get. No ambiguity whatsoever, provided it works out in a way that you have the angle you're looking for in between two sides. Does it make sense? So what I'm saying is, if you like law of sine, nothing wrong with it. But you have to know that it's possible sometimes to get a second angle. You might end up keeping it. But you can easily, realize that it's not going to work, right, by looking at, the third angle. But I'm saying that if you have SAS, you have two sides given plus an angle, right? Where not the angles given, try the law of cosine. In this case, finding the angle straight from inverse cosine in a triangle will always work out uniquely, right? So you need to know that.